Okay, so if someone will join later, so they can just see the record because I think we should start. So hello everyone for a second training what we prepare for you on Saint-Gobain Safe International, and we will talk today where we finished on Tuesday. So we will continue with the house what we create, and we will just explain to you how to change different things, how to optimize or make some modification of the construction of the size of the window and other things. What can help you to optimize your building according our needs for the student contest. At the beginning, I will again share my screen and show you where you can find all this information according or with what is related with the architecture student contest. So you can go to the websites of the architecture student contest. You can click on edition 24, but generally the mine screen is edition 24 in Helsinki. And if you with your mouse scroll down, you can find information about SketchUp plugin here, so you can easily download it. And here will be also two screens from records from Tuesday, what we already made, and from today. On Tuesday, we explain how you can install the plugin of Saint-Gobain Safe and how install SketchUp and what kind of license number you need to put there. And today we will go direct to the model. And for it, I have here again my colleague Miguel Angel. So Miguel, if you can share your screen and we can continue.
Okay,
If you have any
so,
question, please put it to chat or raise your hand and we will go back to you and try to answer it. Okay, Miguel. So here you can see where we finished on Tuesday with this model of the house, and we will continue today with modification and optimization of this house.
okay,
No
this
tener
is okay. We
noches
were
buenas no se debe solo al ruido fuerte. ¿Tú duermes o
uh,
descansas?
I
you
mute,
hearing that?
yeah, I mute him, so no worry.
Okay, I don't know if it was something coming from my computer. Okay, yeah, I think we finished with something like this the other day. Okay, this is okay. Really, it's an example, and if you can remember that, we improvise it during the course. So when we ran the simulation and when we went to the results, we found that okay we weren't complying. Okay, it's not a big difference, but the limit value is 15. We are our heating needs now are 18.9. Okay, we are not complying also with lighting autonomy. And okay, so what we are going to do now is we are going to play a little bit with our model. Okay, trying to fix these non-compliances and at the same time trying to learn something about new commands and how to modify the envelope or how to modify the constructions in order to solve these non-compliances. So, okay, let's come back to SketchUp. And the first thing, okay, I'm going to do is to save this model with another name. Okay, so here, an important thing to remember is that when we are working with this, with OpenStudio models, with the SG-Safe models, we don't have to use the file options because these are for SketchUp, but we are working now with an OpenStudio model. So it's important to remember that when we have to open a model or we have to save or save as a model, we should use these buttons here, these ones, okay? So I'm going to save it, for example, in another folder that I'm going to call day 2. And I'm going to rename our file as day 2. So, okay, I think that one interesting function that I can use, especially in the earlier phases of the project, is a tool that helps up to introduce the windows by a ratio. Okay, for example, I want to have this facade with a 50% of glasses in that facade. So how can we use it? The very first thing to do is to select the faces that you want to introduce the window to wall ratio. So for example, here I have a very useful tool that help us to filter, to search for specific surfaces. For example, I'm going to search for surfaces. Subsurfaces will be the windows. Shading surfaces, we will see it later, are shading surfaces for because of the environment or because of I have an overhang or something like that. So I'm going to search for all the surfaces of the type wall that their condition, their boundary condition is outdoors, and the orientation are, for example, in the south facade. Okay, that's 180 and 180 degrees. So if I search the entire model, I can see that we have selected the south facade of our window. Usually, this green axis is pointing to the north. So if that direction points to the north, this is the south facade. So here we go to EduSafe International. Here in other tools for Windows, we have this option, Windows to Wall Ratio. Okay, for example, if this is the south facade, okay, it's what we call, it's a captive sun radiation facade. So we are going to try to open this facade to the south, to the sun, in order to reduce the heating needs of our building. For example, okay, I'm going to try to have a big opening in this facade. When I click accept, okay, you see now it has replaced the initial windows that I had in that facade by these new ones that are more or less, okay, not more or less, are exactly 60% of the facade. I can unhide all, and then okay, this is my new model. Really, okay, and what I'm going to do is I'm going to run again the simulation now and see what is happening with the results. Okay, I'm going to run the simulation for day 2. I go to the reports level and I'm going here. Okay, so I find now that our heating needs are still not compliant. Okay, but I guess we are a bit closer. Really, sometimes if I want to compare the results that I had before with the new results, there is a small trick that I can use because these reports are stored in an HTML format. That means that if I go to that folder of the initial project, here it's in my case, it's always projects. It was day 1. Day 1, I mm, I enter also in day 1 and again, and here you can find a folder that is called reports, and here we have the reports of the day 1. Okay, these are the results that we had at the beginning. So okay, this is good in order to compare where were we before and where are we now. So before we were with an energy need of 18.9, and now we are with 17. Okay, we have improved a little bit, because we have a bigger uh, area to the south, so solar heat gains are bigger now. And also we can see a difference in the lighting autonomy. Uh, Before we have a somehow poor lighting autonomy, but now as we have increased the south opening, we have a larger windows. Okay, we have a little bit better autonomy. We have more natural light in our building. So, okay, but we are still not complying. So what can we do now? For example, I guess maybe that if you need natural lighting in your building, okay, you need more openings in the rest of the facades. So, okay, let's try, for example, to have some openings in the north facade. So, okay, now this starts maybe like a little game. Okay, what can I do? Okay, so to improve these results. So the very same thing that we are doing here, we are going to the north facade. I'm going to filter all the walls, type wall that are facing to the north. Okay, when we search now, I find, okay, where's the surface? I'm going to outdoors, just in case. So I repeat the same command than before, but we are going to choose sorry, I'm going to use the English International Version, other tools, Windows, Windows to Word ratio. Okay, I'm going to choose a smaller ratio because, okay, in the north, we have natural light, but we don't have so much solar radiation, especially in winter. So if I have a big opening in Finland, I guess that's going to increment a lot our heat losses. Okay, this is not happening just the same in all the countries, because okay, it's related with the it's related with the weather, how cold is the weather, and how sunny are the days in the weather data. But I guess in Finland, if I increase the north facade openings, the heat losses are going to increment. So I will introduce, for example, a 20% ratio for that facade. Now our building would be something like that. I think I mentioned the other day, okay, but probably you are not going to have a unique window in that facade, and you are not going to have a unique window in the north facade. Probably you are going to have multiple smaller windows. But here we are in a previous phase. We are analyzing, okay, about okay, what's the right amount of openings that I should have in that facade in order to have lower heating energy needs and in order to have enough natural light for the building. So it doesn't matter so much the real size of each window, but what it matters is the total amount of windows that we are having in that facade. So
Miguel, I will
okay, let's.
just mention. Miguel, I will just mention that in very often in the situation it is opposite. Architect
Mhm.
just finish the idea of the house, finish all the ideas, and after they do calculation and see, okay, and it didn't pass. What should I do? So this is really important for the students. Then at the beginning, at least you can just check quick calculation according this model or your idea if makes sense, because otherwise you need to improve the material, and okay, you can fix it also after. If you replace, I don't know, a standard window with a triple glazing, the best glass what is on the market. You can put a huge thickness of insulation, and somehow you will reach the numbers, but it will be really
Mm-hmm.
expensive solution in reality. So,
Mm-hmm.
Miguel already mentioned it. It's really good to have this idea at the beginning, so it's better to start with the idea also according to the, how to say, the area of the window. Sorry to not
That's
interrupt you,
right.
Miguel. I am
Mm-hmm.
just trying to explain to the students. Then it's
Yes.
better to do it also in the, how to say, in the early stage, and
Mm-hmm.
be sure then the idea is okay, it's good. Yeah.
Okay, I thank you very much. I appreciate your comment. I always say that energy efficiency analysis should start at the very first beginning phase of the project, at the very first idea, at that moment that the project is a shoebox. Okay, just so a few facades, it's an orientation, it's a localization. Okay, you should start there then to analyze the energy efficiency because sometimes, okay, what we are doing now, the window to wall ratio, it can help a lot in order to comply or not. Or it's more or less the same. Okay, you can decide a construction system. You can decide what's going to happen with the thermal breaches because everything usually everything that you don't solve with a design, everything that you don't solve with a construction of the envelope with the envelope, eh, probably you will have to fix it with systems, with HVAC system, better and more expensive HVAC system, or you will have to integrate more renewable energies with a photovoltaic panel and so on. So it's very, very important to start analyzing the projects in the earliest phase, when the project is almost a shoebox, in order to see where are you. Because okay, sometimes you can make a decision there that could impact very strongly on the development of the project. So, okay, we have run again the simulation, and as I mentioned before, as we have a bigger opening in the north, our heating needs have increased a little bit. Okay, this is a bit funny, but if this is something that is happening in Finland, if you with the Finnish weather, if you if you do that in other climate zones, and that are with a winter that is not so severe as in Finland, probably increasing the north openings with a triple pane glass as we are doing now, it won't increase the energy needs. Okay, so this is something that simulation models teach you about these things. So as we expected here in Finland, increasing the north opening has increased the energy needs. We will take care about it now. And okay, it has increased our lighting autonomy. Okay, we have not reached the requirement. We are very, very close. I guess if you just have some openings in the east or in the west facade, we will comply. Okay, but let's try it, okay, to play with something different. Okay, let's try to meet this requirement, increasing the isolation of the envelope. Okay, let's play a little bit with the construction sets. Okay, I'm going. uh, Really, I want to have this as reference values. So I'm going to do just the same thing that I have done here. I'm going to open day two reports and this. So I can have here in Chrome, okay, this is where we started, or where we finished day 1, and this is the actual compliance of the requirements. Yeah? So I'm going to close the Open Studio application console, and I'm coming back to SketchUp. So what I'm going to do, I remind you that when we define, okay, this is a space with these characteristics. We say, okay, it's the living space, residential living space, is heated and cooled, okay? And the construction set we assigned to it, it was called high insulated my construction set. This is because we modified the other day one of the pre-existing construction sets in order to change whatever I want. So what I'm going to do now is I'm going to work with this construction set, and in order to try to meet the energy needs requirement. So I'm going to cancel, and first of all, I'm going to try to explain you these different rendering modes that I have. Here we are displaying this model with a rendering mode that is called render by surface type. Okay, that means that yellow means that is a wall, this red, dark red means that is a roof, and this gray means that that's a floor. If I click in the other icon here, blue means that that surface is in contact with the outdoors environment, with the exterior air. If I go to the floor, I see that is something like brown, like orange or yeah, orange, I guess, or brown. Okay, this color means that that surface is in contact with the ground. And if I click here and I open this space, I see a green surface. Okay, that means that is in an interior surface. That means that mathematically all the losses from this space through this surface will go to this other green surface that we have here, in the bottom space. There is another rendering mode that is called, okay, let's wait for the tip, render by construction. Okay, here, this is a way to check the different constructions that we have in the different surfaces. Okay, everything that has the same color means that it has the same construction. So what I'm going to do now, okay, is I'm going to change the construction set. So I go to International SG Safe, I go to Construction Systems, I go to Define Construction Set. I'm going to select the construction set that I define the other day. Okay, and you remember this is the construction set that we have assigned to our spaces. Here I can see, for example, that to roofs I have assigned to, for exterior roofs, I have this construction assigned. If I want to improve the isolation of my roofs, I have to insert here a roof with a higher thermal resistance than this one. So what I'm going to do is I'm going to close this window. I'm going to International SG Safe. I'm going to define construction systems, and I'm going to check what, yes, what are the different options that I have already predefined for the roofs. For example, I have a construction that is called pitched roof that has a resistance of 10.58. Sorry. I have roof 1, roof 2 will be 10.60 something. Pitched roof will be 11. It will be a bit per more. And we have something more. Pitched roof 5. Okay, pitched roof 5. Okay, this composition with all these layers here has a much bigger thermal resistance than what we have now. So, okay, if I don't want to select and to make a new construction or change an already existing construction, okay, I can just select pitched roof 5 for the roof, for the exterior roofs. So this is what we are going to do now. Don't worry, because later we are going to modify an already existing construction in order to increase the isolation level of the wall. But for now, for the roof, we are going to just to select this construction. Save or cancel, really doesn't matter. Okay, I want you to notice that now the roof are in this light blue color. Now, but let's go now and change the construction set. I select my construction set and I'm going to replace what I already have selected for the roof with that construction pitched roof 5. Just drag and drop, save and exit. And what has happened? You remember the roof had a different color before, and now it has a red. Well, before it was blue, now it's red. Okay, this is good because we have changed the roofs, exterior roof construction for the selected construction set. So, okay, let's run again the simulation. We are going to be doing this the whole session, changing things, running simulation, and see what's happening. Okay, let's run the simulation. Done. Okay, what has happened to the results? Oh, good. We are complying again. Okay, you remember we were above 15, and now just because we have increased in, we have selected a higher insulation roof. Okay, we are complying again. Okay, but okay, don't call victory because we are still missing the autonomy values. So really, we have, okay, how can I comply with natural daylighting? Because this is about how many hours a year do I have natural lighting above 300 luxes? Okay, really, we have a couple of options. One option is what we are going to do is just to increase the openings that we have in our building. We have also another option that we are not going to go that way, but it's important for you to know because it's the other option is related with the visible transmittance of the glasses. You can always use, for example, construction systems, glass definitions. It's not there. Okay, it opened it in another window. Okay. Different glasses have different visible transmittance. Okay, the thermal properties of the glass are, of course, the thermal transmittance is the solar heat gain. And this is the ability of the glass to block the solar radiation, and the visible transmittance is the fraction of the visible light that is included in the solar radiation that can get into the different building. So one possibility is to try to improve this visible transmittance. Usually, sometimes it's something tricky because this is what is a property that we say about glasses. Okay, that when we say a glass, a selective glass means that it's a glass that can block the solar radiation, but at the same time, it lets natural light to get into the building. But anyway, here we are in Finland. We are not having much problems about overheating, about blocking the solar heat gain. So really, this is not the case. I guess here we are using glasses that, of course, are very isolating glasses, but they are not with a low solar heat gain coefficient, because we don't have much problems here blocking the solar radiation. Just the opposite. We need to introduce that solar radiation into the building. Anyway, so what we are going to do is, okay, this is a stupid example, but we are going to do is what we are going to increase. We are going to introduce some openings in the. Okay, this is north. This is south. Okay, this is the east facade. So, okay, let's work as we have been working before. We select surfaces, type wall, outside boundary conditions, outdoors, and 90 degrees, 90 degrees, 90 degrees, search the entire model, and here we are. Okay, these are our south facades, the east facades. So let's introduce some ratio, window to wall ratio, and okay, I guess a 20% would be enough. Okay, but what has happened? We have a window here, but we don't have it in the upper part of the surface. Okay, this is because this tool is working only in rectangular walls. And as the first floor east facade is not a rectangular wall, it cannot introduce the window. So what we are going to do is we are going to copy manually that tool from here to there. So I open the space. Really, I'm going to click out the hide rest of the building. I just select that window, control copy. I close the space. I pay it. Okay. Well, I'm not sure why. Control copy, control paste. Okay. I'm going to paste it, but okay, really I have to paste it, but I have to paste it when I have our model that is open there. So I'm going to escape. I'm going to double click in order to open it. And I'm going to paste it. I have to be a bit careful because I don't want to, it should be, for example, here, I was concerned that the window is not going out of the wall. That would be a little problem. Okay, it's not perfectly aligned, but really with the bottom of the window, but really it doesn't matter. What really cares is about the size, the percentage of the facade that is with a with an opening. So okay, let's run again and see how things are going. Run, run, run. Are there any questions there? In the results, red color means that we exceed the requirements. How it can be changed? Well, okay, we are doing that. We are changing things in order to fit it. Okay, I'm going to so we have opened our model. Okay, now we have opened to the S, so we don't have problems with the autonomy, but we are experiencing now problems with the cooling needs and the heating needs again. Yes, because, okay, we are opening, okay, the thermal transmittance of the glass is higher than the thermal transmittance of the wall. So if you increase the opening, in this case, we are increasing the losses. So, okay, this is somehow what we expected. So in order to fix this, what we are going to do is we are going to change the walls. We are going to change the construction assigned to the walls in order to reduce the heating needs. And then we will see what can we do regarding the cooling needs. So here we are. I am going to the construction systems, define construction system. And what do I have? Okay, for walls, I have wall ethics 1 with a resistance of 9.1, wall ethics 2 with 10 point, I don't know what, wall ethics, wall ethics 5, wall ethics, okay, wall ethics 3. Okay, I'm going to start with wall ethics 2. What I'm going to do here is I'm going to duplicate this. Vamos a llamarle, okay, let's call it presentation. And we are going to modify these layers of materials, of different materials. So I'm going, I see we have a vapor barrier and okay, with a 0. Okay, this is something that I wouldn't do. Of course, we have a vapor barrier, but it doesn't increase the thermal resistance because its thickness is very, very low. So probably I will have deleted it. And what I'm going to do is to introduce, instead of that, a new isolation material. Okay, really, I will use a bool is over. Really, I don't know. Okay, I have so now we have
Here
a
I
lot
will,
of resistance.
I will, yeah.
Yes.
Here I will just mention that in normal situation you need to keep the vario or other vapor retardant inside for the function of the construction in case of the moisture management. So this is because Miguel just show you how you can change the things. But in normal
Yes.
situation, according to thermal losses, the vario plays almost zero role because the thickness is almost zero. But in case of the moisture measure, this is important layer, you know. but for this calculation, we don't calculate the moisture management, but only the heat losses. Yeah. So this is just for explanation, you know. Then I would like not to show them this construction without vapor retard, you know. Okay.
So this is a presentation and just show you how to add material or how to replace a material. Okay, so think of it as that. Let's save and exit wall ethics 2 presentation. So we have create this new construction system. We can do just as we done before. We can have a look. Okay, now our facades are this yellow. So if I go now to construction system, the theme construction set, I select my construction set. I search for wall ethics 2 presentation, and I replace all the exterior walls with this construction set presentation. I click Save and Exit, and you see that now our facades have a different color because they are made with a different construction systems. So, okay, let's try. Let's cross our fingers in order to see if everything now it's okay. Probably what's going to happen is that the heating needs are going down, but at the same time the cooling needs will increase. Okay, this is a very well-known thing in energy simulations. Okay, you see now we are complying with the heating needs, and we are not complying with the cooling needs. And if we compare it with the previous situation, we see that heating needs have gone from 15.6 to 14.2, but the cooling needs have increased. Okay, this is somehow something that is artificial. It's because, okay, in simulation, we don't have a user that opens the windows of the building when it's hot inside. So we have a fixed schedule for ventilation. It's the same fixed schedule for ventilation in this simulation and in this other simulation. So as the simulation user is somehow a bit a dummy, and it doesn't open the windows when it's needed. What we have is that if we have increased the isolation of our building, it's hotter inside our building in summer. So that makes an increase of the cooling needs. So, but anyway, what can I do now in order to reduce these cooling needs? Okay, in order to reduce these cooling needs that actually are now 16.6, we are going to introduce some overhangs on the south facade. Okay. So how can I introduce overhangs in the south facade? We have a tool for that. The first thing to do is to select those windows where you want to introduce that facade. We search, we get the filter command, but instead of selecting surfaces, we are going to select subsurfaces. Okay, outside boundary conditions, really, I just want to select those that are on the south facade, 180, 180. I search the entire model, and here we are. We have select all the surfaces that are in the south facade. So what I'm going to do now is to other tools for Windows. We have here this tool. It's an overhang. If I click here, an overhang, I can say I can define these windows with this, okay, this overhang with these parameters. The projection factor, okay, this is the length of the overhang, and the length is going to be a factor of the height of the window. So in Spain, I used to, okay, I know that with a 0.3 factor, it's a good protection for a south-oriented window. And the distance factor is okay. It's the distance between the top part of the window and the starting point of the overhang. I'm going to explain it in a minute. I'm going to write, for example, 0.05 distance factor, and just click accept. And here you see we have those overhangs. They are rendered in a different color, so you can notice that this is an overhang. The projection factor means that we have introduced a projection factor of 0.3. That means that this distance here, this distance from here to here, is 0.3, the height of the window. And the distance factor is that this distance here is 0.05, that is the height of the window. It's usually important to have some distance here in order to avoid shadowing our window in winter. But this SketchUp has a very useful tool for analyzing these things. I'm going to unhide all the surfaces. Here we are. So we can run the simulation and see the results. But as I mentioned before, SketchUp has a very powerful tool to analyze these things, to analyze shadowing. If I click here in shadowing, I can see the shadows in my building. Of course, the shadows depends of a couple of things. Depends of the time of the year. These are the different months of the year, and it depends on the time of the day. But when we are analyzing this, for example, let's suppose I am in winter in January, okay, and I am at midnight there. Okay, really, this is not a realistic shadow for Finland. Why? Because Finland is really in the north. It's a latitude, okay, I don't know exactly. So the problem here is that we don't have we haven't geolocalized our model. So, okay, this shadow is for a latitude of 40 degrees. So this is not a realistic shadow for our project. What we are going to do now is to geolocalize our project in order to have the right information, in order to have the right analysis. So how can we do that? Here we have a button that is called geolocalization. I guess here also in the file menu, we have the same option. And this is a very interesting tool in SketchUp. Cancel. Okay, I'm going to click here. And I'm going to click here in Add Localization. I click here in Add Localization. And here we have a map where you can write an address or you can move with the mouse to wherever you want. So, okay, I want my building to be here, for example. And I'm going to click here and select the region of the, it's going to select this image, and I'm going to import that image into my model. Okay, so here we are. This is a very interesting tool for a couple of reasons. The first is that, okay, sometimes if you have um, the drawing of the city, you can make, you can check if the dimensions of your buildings are okay, if the orientation of your model is okay, and otherwise you can correct it. You can also use this drawing, it's in real scale, in order to draw, for example, the shadows that are casting a building that is in front of you. So it has many uses. So now I can see that the latitude, sorry, that the latitude of Finland is 60 degrees. So in January, our shadow, of midday shadow, it's much longer, as you can see here. Pardon me. Okay, sorry for that. I'm here again. So, okay, the shadow of a building is much longer in January. And I guess in summer, summer, it will be also longer. Okay, so, but we want to analyze not the shadow of our building. I want to analyze what's happening with the shadow of our overhang. So I see that at midday in January, it's not casting any shadow on my window. And this is the importance of this cap here, in order to avoid shadowing our window in winter. So this would be, I guess, okay, you see, this would be more or less a good design. Okay, maybe it's even too much, okay, but it's important that we don't shadow our window in winter. So that's the importance of that cap. So when we go to summer, and this is the month, okay, but okay, really I'm used to work in Spain, so usually we have a much, with this small radio, I have a very big protection. Probably I will have a complete protection of the window in the summer months, because in Spain the sun has a much higher height, solar height, so it's protecting almost all the south. Yes, Karel, were you going to say something?
Yeah. I will just mention, and this is a really good example how important are the climatic data, what are already implemented in the software, and you can also download others at Energy Plus web page, where you have lots of data, climatic data from worldwide. But here we just predefined the most important cities, and each year we will do updates if there will be in some city what is not in the database, so we will just put it automatic inside, but it also easy to download direct the city, what is missing, how I mentioned from the web page, Energy Plus, and weather data, and you can easily put it to the folder where are the climatic data for SketchUp and Saint-Gobain Safe. And one other option, this is what I would add, you can also replace the glass with other glass with a lower solar factor. So if you sometimes it is not enough, and you should do combination, but it's also other option how to little bit reduce the problem with the overheating. So maybe in the Helsinki it will be not a big deal to do it, but I don't know. The student contest already was in Dubai, or we already had it also in the Spain, in Madrid in the past, and for this kind of sound south areas or countries, this is really sometimes really important, sometimes even more important than the issue with the heating during the winter. So for these countries, it's more important to cover the houses against the overheating during the summer. So this is just one of my comment, and Miguel, please you can continue.
Yes, I'm just going to run simulation. See, where are we?
Miguel, we don't hear you. I don't know if you are mute or okay. Oh, okay, okay,
Just having a look.
okay.
So now our client with the cool lights and the Python.
We don't hear you so well. So if you can speak louder, or if you change the volume.
Oh, sorry.
Okay, okay,
There I
okay.
cough. I
It's much
raised my
better. Yeah, yeah.
microphone.
Thank you.
Yeah, sorry for that. So now we are compliant with both heating, cooling aids, daylighting, and so on. So okay, really, I think I have taken a very short. Okay, I'm going to delete this terrain. I have to unlock it, I guess. And now I can delete it. I localization spot and block. And I think I can delete it. I'm going to insert it again. Geolocalization. I'm going to select a bigger area. Okay, okay. What I was going to try to explain. Okay, sometimes. Okay, no, I'm going to geolocalize in another place. That's it. In order to show you with a more realistic case. What we have here, location here. I geolocalize.
I can give you the exactly the location of the contest, but I think it's not so important for this training.
Okay, yes, but do you have the right? Can you write it in the address in the
I,
chat
I
and
I
we
don't
can
know
have a
if
look
there
at it?
is really address, but at least I will check if I can help you with the pictures or something. Yeah.
Okay. Anyway, let's suppose that our building was going to be here. Okay, I'm going to select the region. Okay, this is enough. And select region. What's important? Okay. So, okay, this is a small house. And now I can properly locate it for just moving. Okay, I can select everything and I can move it from here to here, for example. Okay, I can, for example, correct. Okay, I was drawing everything, supposing that it was aligned with the red and the green axis, but in reality, there is a small rotation here. So, okay, first I have to select. Yeah, I switch to select model. I select everything, and I can click here and suppose it's slightly torn. And now I was wondering if these buildings that we have in front are casting any shadows that can affect to my house. So what I'm going to do is I'm going to draw. I'm going to draw a shadow that represents these buildings that are in front of me. How can I do it? Okay, I can draw, for example, a line from here to here, more or less. And I'm going to use it as a reference. I'm going to copy. And now here, this is the tool for creating new spaces manually. And here, this is the tool to creating group of shadows. So I click here. I'm going to select this as the origin of the shadowing group. And now I'm going to draw, let's say from here to here. Sorry, no, that's not the right way. Okay. Okay, let's do it manually from here to here. Let's suppose it's 9 or 10 meters cave. Okay, sorry, this is not right. Okay. So now this shadow represents these buildings. So as we have done before, in order to have a sense, okay, is it going to affect or not? Okay, let's go to January here and let's see what happens. Okay, you see that it's casting a little shadow that probably is affecting, probably, okay, it's affecting a little bit to the first floor of our building. And okay, and what's happens in summer? Okay, this is the problem of shadows. Okay, in summer it's not protecting us at all. Okay, you see, in the summer months, okay, the shadow maybe I don't know if you are okay if you are seeing it because it's okay. I'm going to hide this maybe if I hide. How can I do it? Let's look here. No hide. Okay, I'm going to delete it. Desbloquear. And okay, now it's easier. So, as was mentioned before, in winter, a better, okay, you see that noon, we have some shadows here. And then, but in summer, okay, shadow is much more shorter. So, okay, now we can have a problem because as we have this obstacle, okay, this building that is, okay, really this is very special case in Finland because really this building is very, very, very far. Usually in France or in Spain or in Italy, okay, this building won't be affecting at all to our building. But due to the high latitude of Finland, okay, this building that is so far is affecting to the solar gains of our south facade. So, okay, let's cross our fingers and let's run the simulation and see what happens. Okay, let's run. Let's go to results. Oh my God. Okay, it's not complying. It's not complying again, but you understand why. It's not complying because now we have shadows on our south facade, so we don't have as much as free energy coming from the sun as before. Oh, and it's also affecting to the daylighting autonomy of the first floor due to the shadows of that facade. So, okay, we have a very simple solution.
Miguel,
Okay.
I will just mention one more thing because we are all the time talking about envelope. Also the daylight autonomy is calculated according how to say the middle of the first floor. So if you will put also partition and something other construction inside, it is possible, but it's not related to thermal losses because it's inside construction. Like the floor between two floors. And second thing is
Yes.
the daylight autonomy is only inside. So there is some kind of sensor what is doing the calculation inside the house. So if you split it the house with a different partition for the daylight autonomy, you need to do separate calculation only with one room. So this is important because in our case we don't have any partitions inside and we are doing it like big space or open
Yeah.
space, and we calculate it like one room. But if you would like have many rooms inside, you need to do it only for one room, what you will choose
Yes.
separately. So you need to maybe one model for the heat losses and the second one only with one room for the daylight autonomy. Yes. Sorry.
That's yes. So really, okay, this is maybe it's not realistic because okay, this is a residential building, and here we are having okay. Okay, I'm going to explain it. Really, in order to calculate, the the daylighting autonomy, we are creating an auxiliary model from this one, and I'm going to show you. I'm going to open. Okay, this is day 2. This is day 2 Open Studio model, and we have created another model that is very similar to our model, but we have introduced here a dilating sensor. So, okay, as you can see there, the dilating sensor, where we are measuring the autonomy, is is located just in the middle of the room. So, okay, this can be realistic if we are in an open space. Okay, so you are going to measure dilating in the measure of the space. But sometimes energy models are simplifications of the okay, here. Okay, energy models are simplifications of the real model. One very typical simplification is that you join different spaces into one thermal model. For example, here in this facade, maybe the real building has 3 or 4 offices. It makes no sense to make an office for each, or sorry, an space for each of those spaces because they are similar. And if you make many similar spaces instead of one space that joins all the real offices, okay, the simulation will be slower. And it won't improve the quality of the results, and it will be slower. If it's slower, it takes more time. So you spend more time running the simulation than thinking what can you do to improve your building. So from the thermal point of view, it's very good, join spaces, but the problem comes with the dilating, because it's not the same to have the dilating sensor in the middle of the room that in the middle of the floor space that to have it closer to the window. So what can you do if that's your case? So if that's your case, you have to forget about this result. You have to forget, okay, now it's not complying. Okay, but it's not complying because space 1 is a fictitious space. It's a fictitious open space. Really, in that space, I have a smaller offices, 10 or 12 square meters offices. So what do I have to do? You have to create a new project for dilating analysis. So you go here, you go to SC Safe International, you create a new project, and you call it, for example, dilating, for example. New project created. Okay, this is okay. Really is important. The weather data is important, so you have to select again Finland. Helsinki, here we are, for example. Now here, instead of creating the envelope of the building, you are going to create the real offices, but not all the offices. You are going to create the characteristic offices of the different spaces that you have in your building. For example, let's suppose that you have in the south facade a typical office that is 2 meters by 6, for example. I don't know if that's something that makes sense. Okay, you come here and you say, okay, this is my typical office here, 2 by 6, something like that. And you push it with 3 meters, for example, and here I have as you say, international. Okay, not there. Say HVAC definitions. Other tools. Windows. Window to wall ratio. Okay, I have that window to wall ratio. So I'm going to define it as a space contributing to the reference size. Okay, really here in this model, I don't care much about the construction set because this model, I'm going to use it just to justify the dilating autonomy for the different spaces. So maybe you can have this type of space and okay, let's suppose that here you have another space. Okay, maybe you can also have a meeting room and then you can have a kitchen, whatever. Okay, different kind of spaces. Uh, mm, so you run the simulation now with this model. I'm going to run it. And as this is the dilating model, uh, I'm just going to take care of the results of the dilating. Okay, yeah, I'm not complying, but I will have to increase a little bit or whatever. But I will take care here, not of the heating needs, but just from the dilating requirements. Did I explain myself? Carol, did you understand me? What I
Yeah,
tried to
yeah,
explain?
yeah.
Yes.
I will just mention then for this calculation is not important the envelope, but only this results on daylight calculation. And
Yeah.
if you have this how to say not good numbers, it is because inside, and maybe you can also show the sensor inside what is doing or what we are using for
Mm-hmm.
the calculation. And
Mm-hmm.
you can change the size of the window what you already made, or you can put the
Mm-hmm.
other window or a different kind of
Mm-hmm.
glass inside. So there are many
Mm-hmm.
options how you can do it, but the reason why
Mm-hmm.
in this case it was not enough in the previous calculation was because we have quite a big room only with one window on the one side. So and the sensor
Mm-hmm.
inside what calculated is in the middle. So one window cover mostly the area what is close to the window, and the opposite area it has almost no daylight, and this is why it. So sometimes it's better have more small window than only one big on one side. According
Yes.
to this calculation. I see the
I
sensor already inside, so maybe if you can
yes.
go
Yes.
closer.
Anyway,
Yeah.
yes. This is. I think really this run is too narrow, so it's very difficult to comply with the dilating because it's really narrow. I guess a more realistic case would be something wider. eh? So probably uh, I'm going to introduce the same window to wall ratio, space definition, other tools, windows, window to wall ratio. Okay, let's do it again. And I think probably this will be
Maybe
complying.
you can also add the one more window from the other side, from the
Yes,
opposite side.
yes,
Okay.
that's always
We'll see. We'll see.
a possibility. Mhm. Okay, that's it.
Yeah,
we
but
have a very,
it
very.
is enough. Yeah.
Oh, there is another possibility. I remember, but okay, it's difficult to explain now. Okay, we can increase the reflectivity of the interior surfaces. Okay, but this is a tricky question.
I will not go to these details, but you are right. If you have
Yes,
inside, for example, if the color inside it's dark,
yes, the
of
color
course
inside, yes,
you are
yes,
losing, and
because
if this is white or with higher
yes,
level of the
it's
reflection, so it is better.
yes, because we are using by default a very, I think it's a 60% of absorbance, so it's really dark color inside, so it's a bit tricky. But
But
if you increase the
Miguel,
reflectivity, yes,
if you also can show us the sensor just for the students, if they would like check if they make no mistake. So if you can show them
yes,
how to check if
okay,
the calculation was
well,
correct. This is
yes,
according to standards, so you don't need to move
mhm,
with the sensor, but just for you to understand how the calculation is made. This is according to standard. So the sensor is
mhm,
in the middle of the room. There are some rules. I don't know, 1 meter on the floor and
yes,
yeah,
yes,
and
I
here we can see it. Yeah, in the middle of the room. Yeah, yeah.
yes, it's in the middle of the room. It's at think at 0.8 meter height. Okay, and really you can move it,
Yeah, but
but
in normal situation, you should keep it. You know, if you would like move it, the
the problem
calculation
if
will
you move
be.
it every time you run again the simulation, it will correct to the center of the
Yeah,
space.
yeah, it will be
So
automatically corrected after. Okay, so
yes.
I think that's all probably for today. We explain you how you can do the modification. So I will just say brief summary. So we show you how to modify the construction, the size of the window, and optimizing it according to requirements from the student contest, the architecture student contest. What you need to reach in case of the heat losses and cooling needs, and in case of the daylight autonomy. These two things we cover already with this software Saint-Gobain Safe International. Next year we would like also improve it for in case of the acoustic, but we will see how we can do it. So this is still not clear right now. And yeah, we finished what we needed to show you. If you have any question, you can ask according your contact for a student contest, and probably I will complete all this question together with others. And if this will be more question on same topic, we will create other training for you related all this question to explain it during one more training. If this will be different one or basic ones, I can also answer you how to do it and how to fix it. So okay, so there is one question in the chat: when we will HVAC issue? Okay, HVAC system. So maybe
Okay.
Miguel, if you can, we have 5 more minutes. If you can also show them something about HVAC.
Okay. I'm going to open the two projects. Here we are. And we have here in the national HVAC definition. Okay, we have a few options here. Uh, I think they are really easy to implement. For example, let's suppose I want a central boiler and baseboard and baseboards. Okay, if I select these spaces, both the spaces, what's happening? I think I have introduced the shadow as part of the space too. Okay, it doesn't matter because it's shadowing everything. But okay, if I select the two spaces, I can go now to HVAC definition, and using this tool, it will introduce one boiler and two baseboards, one baseboard for each space. In reality, usually you have multiple baseboard, water baseboards in a building, in a space. But here, this is a theoretical value that, okay, that is including, okay, a baseboard big enough to meet the energy needs of the building. So if you select the following option, individual boiler and baseboard, you will be introducing one boiler for each space. Okay. So, well, let's suppose you have a central boiler and a baseboard. I think it's quite intuitive. It's asking, okay, what's the boiler type? Is it condensing, low temperature boiler? It's asking, okay, you have to tell me the fuel, outlet temperature, and the thermal efficiency. Okay, we have here, do you want to remove any previous HVAC equipment that you have in the different zones? Okay, just in case you are running this command multiple times, okay, probably you will want to replace. So, okay, let's click accept. And for example, let's suppose that now you want to add also some heat pumps for the summer or even for the winter. The procedure is just the same. You select those spaces and you go here, HVAC definition, and okay, we will introduce here individual heat pumps. We have to introduce the COPE, and this is the coefficient of performance. Let's suppose it's a good COPE, that's 4.1. And this is the energy efficiency ratio. It's the same as the COP, but for the summer, from producing cool, let's suppose 3.8. Do you want to remove the current HVAC zone equipment? We will say no, because we have just inserted the baseboard, water baseboard for the window. And let's accept, okay. And now we can run the simulation. We can run the simulation.
I will just mention it, and you can also here in the Open Studio modify some other things. But in normal situation, you do all in the SketchUp in Saint-Gobain Safe, and after the first black screen just transfer the data here, and after here it is the final calculation what is using the Energy Plus score.
Yes. Okay, really modifying things here it's for advanced users. So okay, we go to results. Maybe we can go now to this detailed results. We can have a look at the time. And now here we have the baseboard total heating rate. So, okay, this will be the power output of the baseboard. The other one. And okay, we can have a look. The cooling rate is more the same. Okay, this would be the cooling rate for the winter, for the summer, sorry. And okay, this is a very typical shape in systems because okay, it starts maybe at 3 o'clock in the afternoon, and you have a peak in the power needs because you have to lower the set point. Let's see what's happening with the set point. Okay, let's okay, during the morning we don't have a set point temperature, and at 3 o'clock in the afternoon the set point goes down to 25 degrees. So we have a peak in the cooling production of the equipment, and then it stabilizes to a lower value in order to maintain this 25 degrees. At 11 p.m., the set point raise, so the cooling is lower. Really, I think it's very, very, very interesting because, okay, it's very useful in order to understand how the HVAC system of a, okay, this is a baseboard total heating rate. Okay, it's more or less the same with the heating in winter. Okay, we have a reduced thermostat during the night. In this case, around 8 or 9 a.m., the set point rise to 20 degrees. So we have to give a lot of a high peak power in order to restore the day temperature. Okay, when you achieve that temperature, there is a lower energy consumption for the rest of the day. Anyway, okay, this is okay. This is a very cold day because, or maybe it's a normal day in Finland because
But I
you are
think
all day below zero
yeah.
degrees.
I think,
So
Miguel, I
yes.
think it was enough just to explain the HVAC system. I will just mention that we are already out of the time, so we will finish soon. Just one more information for you. Here in the open studio, you can of course modify something after if you would like, but Miguel already mentioned it is not so easy, so you need to have a higher level of the knowledge into Saint-Gobain if it's more user friendly. But here on the left side you can see the icons and you can go through all of them about the occupancy and a lot other things, how many people it's usually in the office building and for how many hours and so on. But we for the student contest we predefine most of things according to standards, so you don't need to go so many details if you don't like to do it, and you can just use the settings what is already there. And there is one other question: is available any guide to safe Saint-Gobain safe international? This it was the day, you know, this was the training session for the how to use the Saint-Gobain safe international. I don't know if there is some kind of brochure or other movie if you made something, Miguel, in the past.
Okay, but it's in Spanish. But
Yeah,
there
it
are
is in Spain language.
plenty. Okay, you know, this is SG Safe is a layer of an open studio, and there are plenty of resources of open studio in internet. Yes. Anyway, I think if you have any doubt or any special needs, maybe they can contact you, Karel, and we can
Exactly.
see if we can prepare a special video. Okay, for example, if you need, okay, I need a photovoltaic arrays, how can I introduce it? Okay, we can prepare a very short video, 2 or 3 minutes, it won't take longer, in order to explain how to achieve that thing. Anyway,
Exactly.
I would recommend you to, to develop very simple models. Okay, very simple models. You know, in energy modeling, it's not. It doesn't matter very much. It doesn't matter anything at all if the wall is 1 centimeter to the right or to the left. Vale? I know that for architectural purposes, that could be a word, but in energy modeling, it doesn't matter. So try to keep your models as simple as possible. Try to join different spaces into just one big space. Try to reduce the number of walls, try to reduce the number of spaces. Okay, this is a student contest. So it's important, okay, to try to keep simple in order to spend time thinking, how can I improve my building instead of spending time waiting for the results to finish? Because if you have a model with 200 spaces and with 50,000 surfaces, that will be a very, very very, very low model, and the students will spend time waiting for the simulation to finish, and it won't be fun. I think this should be something, it should be fun, okay? So
Okay.
I would recommend you to keep things as simple as possible.
Okay, so thank you very much. I will just show you also my contact. So you can, if you have any question, you can send it to my email. Here you can see it. I also posted to the chat, and we will come back to you and to help to you, or we can have a separate team meeting. How I already mentioned, if I will collect a more similar question, we can create other training session and go through all the question and step by step explain how to do it. I understand, and if you have no experience from the past with this kind of calculation or with this kind of software, it can be difficult at the beginning, and this is why we are here, and this is why we are doing this training for you. So thank you very much. Thank you very much, Miga. Thank you to everyone who were here today, and we will post the recording to the student contest page. So that's probably all. Okay,
Thank
bye
you.
bye.
Bye. Bye
Thank
bye.
you. Bye bye. Have a nice day.